Welcome to PDH Hour with Glenn, the July 2025 edition. This month we're going to be talking about certification reports, signed, sealed, and debunked. So a brief outline. I want to thank you for joining me. First thing I'm going to go over really is why I chose this topic. It was something that I felt burdened with to do. Then the purpose of a construction CQA or construction certification report. The contents of a certification report, basically a compilation of different state requirements, some of my suggested additions as we go through that. Then we'll do an in-depth discussion of each content component, look at typical requirements, the key findings from over a decade of project audits, guidance on avoiding some of the pitfalls we see, recommendations to regulators and to the engineers out there, and then questions and answers. So feel free at the end, if you think of questions, use the question and answer feature on your browser. I'll try to answer them, even if we have to stay a few minutes long. I like to try and answer the questions that I can answer. So couple reminders, prior webinars can be found on our CQA Solutions website, and PDH hours are only awarded for those who attend the live webinar for the entirety of the webinar. So with that, why did I choose a topic of construction certification reports when this topic seems fairly straightforward? Well, I really wrestled with it over the past 10 years. We've done different site audits, and every one we do, there seems to be problems with a certification report. A lot of times these are draft reports. In some instances, they've been turned into regulators, and I don't understand how these things can be certified in the condition that they're in when I review it, and it's really frustrating. And so I thought I should do a topic on this, try and help people understand the purpose of them, what should be in them. So ultimately, I hope it leads to better construction quality, and better construction quality is going to equal to a defendable certification report if you ever find yourself in a legal battle for some reason. So we'll get into the purpose here. I looked at multiple states, and I'm not going to read every word on these, but just try and give you a synopsis. I think a half dozen states or so. I started with Ohio, my home state here. For each engineered component, the engineer, the owner shall demonstrate the following through a construction certification report. One is compliance with a facility design and the authorizing document. Two is that the engineered component was installed in a manner that did not damage the engineered component or other engineered components. And then three, that it's in compliance with construction requirements in this chapter of the Ohio Administrative Code. Michigan, similarly, the construction quality assurance officer shall certify that a landfill was constructed in accordance with a CQA plan, these rules, and the engineering plans approved by the department. And below that is some of the requirements. We'll get into those later, telling you what they expect to see under each of those topics for the different engineered components. Another thing I found interesting that I think is often overlooked in Michigan's code is that an engineer's certification under this rule, is a statement or declaration that is based on his or her knowledge and review of the construction records. This engineer's certification of the construction conditions does not relieve the owner or operator or any other party from meeting other applicable requirements of the act or these rules. I think that's often overlooked. Owners are thinking they got this certification and they're coasting free, but that's not really the case when you look at the rules and you talk to regulators. And I appreciate those regulators that have joined as well today. Wisconsin, I really like some of what I've seen in the Wisconsin rules and looking through them, but again, it's a certification by a professional engineer. They're signing that this document has been prepared in accordance with the rules of professional conduct. And these chapters here, the code, and then to the best of my knowledge, all the information contained in this document is correct, and the document was prepared in compliance with all applicable requirements in these other codes of the Wisconsin rules. So you start looking into some of these things, and the code of ethics, or whatever it's specifically called there, is pretty interesting, what the engineer is supposed to be attesting to. I'm not going to go into all those today. It would take too long. But Florida, another one, the professional engineer in charge of the construction quality assurance shall provide a signed, sealed final report stating that the liner system has been installed in substantial compliance with the plans and specifications of the liner system. And then they require you to sign this form that goes along with the certification, and the form basically says, this is to certify that, with exception of any deviation noted above, the construction of the project has been completed in substantial accordance with the plans authorized by construction. Louisiana, similarly, I think this is the last state that I listed. We looked at numerous ones. I just picked a handful. Some of the ones that we've worked in. The permit holder or applicant shall provide, again, implement a quality assurance, quality control plan that will ensure that the liners are designed, constructed, installed, and maintained properly. All excavations, liners shall be inspected by a certified professional engineer registered in the state of Louisiana with appropriate expertise. And I think I'll talk about this as we go through this. The expertise, is kind of a gray area for some. And I think, that's an area that might need to be addressed in the future. 40 CFR pertaining to CCR closures. I looked at this as well. Upon completion, the owner or operator must obtain a certification from qualified engineer, and it references paragraph B. Paragraph B basically, is listed here for you, basically saying that a written certification from a qualified professional engineer is required unless approval from the participating state director, or approval from the EPA, or the EPA is the permitting authority, is required. So when you really look at it, a lot of it references a quality assurance plan, and it's really, your certification is proof of quality assurance. So it goes back to what we discussed in the previous webinar, the definition of quality assurance. A better definition than the one commonly used in the industry, that we've found is, quality assurance is all those planned and systematic actions necessary to provide confidence that a product or facility will perform satisfactorily in service. And that's often left out of what, is commonly interpreted in the containment industry. Likewise, the primary goal of QA is to ensure that the construction processes are carried out correctly and efficiently to meet client expectations and industry standards. And again, meeting industry standards is often seems to be left out in the containment industry as part of the requirements. And I think that's problematic, and you'll see that as we go through this. So the purpose, key takeaways, basically a registered engineer, professional engineer is signing and sealing the construction report, attesting that construction was performed in accordance with the governing documents, a permit to install, things like the design, construction plans, the CQA plan, technical specifications. Some other key takeaways is that many of these regulations reference other requirements. So it's not something that's really easy to put together. You've got to look and cross-reference things, but a lot of times there's, requirements for the qualifications of the engineer, the codes of conduct, ethics for the engineer, qualifications of the technicians, and requirements for the contents of the construction certification report. So let's get into the certification report, the content, an overview of content, looking at various states. Typically, if you see the black text And looking at various states, the black text is something that's quite common between the states, where the blue text, is things that you see in one state but not another, so it's not as common, basically. So there's usually going to be a narrative required describing the construction of engineered components, include conformance and variance from the design and specifications, weather impacts. Sometimes you see including best practices. Where did you go above industry standards? That's something that I suggest adding is, where did you go above industry standards? What did you do that went above and beyond the governing documents? One of the common quotes that we see, and we've seen it on projects, this project doesn't need to meet that requirement because it is grandfathered in. So, for example, one of the projects we were working on, there's a highway that runs between them. Construction started on the north side and moved to the south side of that highway. Well, there were two different permits, and the quality requirements didn't have to be the same on the north side as they did on the south side. And that's just mind boggling to me. You're constructing something the same year and two different projects. Why doesn't the quality have to be the same on both sides of the project? I don't understand that. I know it is what it is, but to me, if you have industry standards that say you should meet this, you should meet it on both sides, regardless of whether it's being grandfathered in. I don't think grandfathering in is an excuse for poorer quality. Tables indicating project personnel, experience, days, hours on site. Again, not a common requirement, but it is required places. I think it's a great addition. Tables indicating who's responsible for the report, the narrative, the plans. I think that's another good addition that you see in some states, but not others. Daily field logs and reports for each day of construction. To me, that should be a no-brainer that should be in there, but it isn't. It's not required in all the states. And I don't know how you, as a certifying engineer, can, justify if you don't have the reports in there. I get that you may have them in your office, but um, how are you painting a picture of what actually happened? And as a regulator, how are you verifying it without the daily field reports? Those field reports really tell you what happened, or they should tell you. As we go through it, you'll find out they don't tell you much in a lot of instances, but they should. They should paint an accurate picture of what went on each day. More requirements that you see: construction test results, obviously frequency, location, procedures, results. Another thing that you see that's missing a lot of states: RFIs, variance approvals, things like that. To me, they should be an appendice at least in the document, especially when they're being referenced in the narrative, but they're not. And you can't piece together what happened accurately. Survey results, photographs, pretty common. Record drawings for each engineering component, pretty common. And then again, the signed and sealed statement by the professional engineer is common. With that, I'll move into the narrative, and we'll go through the narrative content here. Project description, that's one of the things that is pretty logical, required. Provide a project description containing an overview of the work performed. Some of the ones we've reviewed don't even mention the correct cell. It's like they cut and paste the narrative. If I'm a regulator at that point, I'd throw that thing back to you. I wouldn't even review it any further. I mean, that's just junk to me. I mean, how can you be doing that and you don't even have the unit that you were working in correct? I mean, how do you have any confidence in anything else in that document's correct? I wouldn't. Specific areas of construction, dates of construction, delays in construction, the reason and resolution as necessary, material borrow sources, material sources for manufacturers, material quantities. They should all be included in the narrative and are often required in a lot of narratives. Contractors, what is a contractor's qualification? Some states require to list individuals by position and experience and the responsibilities of those individuals. Then you should describe the general procedures used during construction, what was used by the contractor, and how these tie back into the PTI, the governing documents. Variances again, and their reason for approval, and then issues and their resolution. Material testing laboratories and their qualifications. What are those? Are they qualified? Are they accredited? What is the laboratory qualifications? And not just the laboratory, but the individuals performing the test, because you'll see some crazy results that we'll talk about here. Survey control, both by contractors and the engineer for verification. And then we get into the engineers and the engineering oversight. And I had our team generate this graphic here. It's something that I just drew an eyeball years ago in the mid 90s on a project because I was running two different projects at once. They were the first two that I was the lead CQA tech for, and they were separated by a couple hundred yards. So I had to walk from one to the other. And, there'd be something going on one and something going on another. You walk to one and you got a person overseeing the vacuum testing, and the guy's just moving the box and not waiting the 10 seconds, and you can see it. And the CQA tech's there, and you go back to the other one, and the girl sitting on the generator holding the funnel for the guy pouring gas into the generator on top of the geomembrane that wasn't even supposed to be done on the geomembrane or in the cell itself. And the owners getting mad because the installer is going back and I'm making them redo stuff, and they're complaining to the owner, and the owner's like, "Where were you?" Well, we had a tech there. I can't say, it was a tech that shouldn't have allowed what was going on. That's all I can say. Let them talk to the company I was working for. But um, where were you? And I think that really um, goes to the engineers as well. It always seemed in my career to go to technicians, but I think, that's what I'll get to here in a couple bullet points is where's the engineer? Where's their oversight presence during the actual construction? That's a big thing. The narrative often required, again, the black text is more required. Discuss CQA and engineering oversight qualifications, typically individuals by experience and position. Um, let's see. What specific construction experience training does the engineering team have? Um, that's really a big one to me. And you'll see again, if it's not in the CQA plan or specifications, I can't enforce it. I've talked about that in numerous webinars previously. And that same logic applies to the regs. If it's not in the regs, they can't enforce it. So I disagree with that, and I'll show you why here in a couple slides. But on-site responsibilities of each CQA technician, what did they do? What were their responsibilities? What is their experience? That's often required, and I think it's a good thing. But here in the next section, I didn't see this really in any of the states that we looked at as requirements, but I think it's important. I think it should be there. How did the engineer, you as a certifying engineer, keep your finger on the pulse of the project? I mean, I get the impression by looking at some of the findings that we're going to get into that you were absent. And I don't necessarily believe that's the case. I think engineers believe they're doing a good job, but you look at some of this stuff, it's mind-boggling. How could you sign a certification report where you're present? I think this is a big key addition. The engineer, how did you keep your finger on the pulse of the project? Were you involved daily? You should be involved daily. Um, Weekly meeting attendance and methods, was it remote? Were you on site? I think that's critical. The more on-site visits you can get, the better off I think it is, as long as you know what you're looking for. Um, Number of on-site inspections performed by the certifying engineer, junior engineers also should be listed, in my opinion. Daily paperwork management procedures. What were the responsibilities by position for approval, sign off? Were punch lists generated? How were they verified? You know, Daily field reports should be reviewed on a daily basis. And we've seen in cases where they're not reviewed daily, they're reviewed several months after the fact. And you can't keep on top of a project and keep the quality controlled if you're not reviewing it on a daily basis. Uh-oh. I don't know why it's not letting me advance it there. There we go. Yeah, sorry, glitch here. Now I guess I got it back. All right. Narrative and the CQA and engineering oversight continued. Again, it should describe the procedures. This is a common requirement that what was done by the CQA people, how did they verify that the construction met the requirements? What observation and documentation methods, what testing methods were performed, equipment calibration, and failed test resolution, rework, repair procedures. Describe the quality initiatives that went above and beyond the requirements of the guidance documents. Again, it's not a requirement that I found in all the states. I think maybe I've seen it in one state, but that's what we recommend putting in there. An example would be, okay, we required vertical trial seams to be performed when vertical welding was performed. Those are things that you can do to verify the quality, and if you're doing those things, you should put them in the report so the regulators understand that you went above and beyond in certain instances. There's usually going to be a conclusion in your narrative, summarizing why the activities described in the report meet the regulatory requirements. And I don't know what happened to my text there. Somehow my text disappeared. Oh, there it is. Contain references to appropriate appendices. We read the narrative, and we'll get into it in our findings here, but um, appendices are misreferenced. The information isn't there. Um, but I'll talk about that here in a minute. Um, so what do we find in the narrative? We find all kinds of things. And, like I said, the project description's incorrect or incomplete. I just throw the report back to you at that point. I mean, I don't even want to look at it any further if I'm the regulator. Stated project construction practices don't match out of supporting document. Say a CAT 825 was used for the compaction, and the forms and the daily field reports will contain an 815. So what was used? The photos, can you look at the photos? A lot of times, unfortunately, the photos are missing, or they don't show the logo or don't show what it is. Sometimes you can't answer it based on photos. The thicknesses and compaction of materials, they're missing. Testing equipment substitutions were made. They're not documented. They're not even approved necessarily. We've had, e-gauges used in place of nuclear density gauges that we found, and there was no approval granted. You couldn't find any variances. Um, Issues that are not mentioned, not properly repaired when they're stated to be. You look at the field work reports, quantity of materials don't match. Pre-construction conformance testing frequencies are not supported by the documents. So, you might have something specification for geosynthetics material, 1 per 100,000 per batch, and you see that it's, 1 per 150,000, 1 per 200,000, and there's different batches that are missed. Materials are frequently used that don't meet the stated material or criteria. Sometimes you see that, especially in soils where they use the wrong material. Something's designated for a structural fill material, and they're using it for an RSL, and it doesn't meet the permeability requirement. We've seen where the clay content isn't meet the reg spec. We've seen different size specifications aren't met, things like that. Improper tracking of failed destructs. That one happens quite a bit. I already mentioned the appendice references being incorrect, or, sometimes there's not enough data even contained in the appendices for the construction records. We've seen where you have a year-long project and you only have data that goes through 6 months of that. And, I don't know how anything gets approved like that. As I mentioned, your narrative, if you had a substitution, it should be documented. The C gauge was used, in a case where it wasn't documented. Nobody could find an RFI. I don't know whatever came of that on our audit, but was it a viable substitution? There should have been some comparatory analysis, probably some regulatory buy-in before they used it, but there wasn't. So, things like that you want to look for in the photos. As a regulator, you should familiarize yourself with the gauges, what type of gauge is approved. Some might be a CPN, Troxler, the other manufacturers. Are they, taking the tests at the appropriate depth, the requirements? You should familiarize yourself so you can recognize if you're out there in the field, things that don't meet the spec, or you can recognize it from photos. So those are just some tips there. Getting into project personnel and the requirements. What we find, unfortunately, is personnel are incorrect and or missing a lot of times. There's names on resumes submitted. You start looking at the actual daily field reports. You start looking at, logs for the different earthwork or whatever the logs may be, geosynthetics logs, and you'll see initials and they don't make any sense. And you find out that those personnel weren't even on the project. A lot of times personnel experience doesn't meet that required. This middle one, is a big one that we're trying to work on. How do you actually make this more of a solution in the industry? We try and offer training for this reason, but experience doesn't equate to actual knowledge. People can have 100 acres of management, but if they've never been out there, they never experienced it, that knowledge may or may not be enough to actually properly manage and oversee a project. Field CQA people have no clue what their responsibilities are. That's another big one. Most people think they're out there just to document, and most engineers think that's what their role is, but they really need to be keeping an eye on what's going on and making sure that the project's being properly installed. Required full-time CQA component. Sometimes it's right in the regulations. This is required full-time, and you start looking at the documents, and it's part-time. Technicians are only out there part-time. The activity obviously was based on looking at logs carried out full-time. How is that certifiable? I said project personnel. I've used this slide in the past. You have your two CQA personnel down there. They're watching this guy weld and do a repair. He's already ground through the paint, and that's a big no-no. Your weld's not going to pass going through the paint, and it's going to carry the grit's going to carry the paint to other portions that you're grinding. And so they're doing a poor quality weld, and the CQA techs are down there, not paying any attention to it. Then on the photo on the right, you have the CQA tech that's standing way too far back. At least he's present for the vacuum boxing, but he can't confirm anything. And the condition of this vacuum box, I know, had leaks from our audit, so people don't know what they're supposed to be doing. And the engineers were on site. They walked past all of this stuff during our audit as well. And so there's a big problem in that regard. So you got to know what to look for. Okay, moving on to daily field logs. Sorry, I'm trying to get through this. I know there's a lot of content, and I tend to ramble here when I'm doing these because I think of more things that I want to share with you. But daily field logs and reports, they should provide a detailed summary of the construction activities for the day, including areas worked, contractor, personnel, equipment on site, procedures used, approximate quantities of materials constructed, CQA personnel on site, what activities they monitored, tests taken, samples taken and submitted to the laboratory, issues and corrective actions, and then references to documentation forms. And you'll see this in a lot of regulations, but that's not what you're seeing that's being turned in. And it's kind of mind-boggling, but a lot of engineers take this minimalistic mindset approach. They believe less information is better because it gives regulators less to be able to cross-check. And less problems potentially to find. And, I get it. And early in my career, on a job or several jobs, and, we'd wait for the regulatory feedback, and we'd get, hundreds of questions. And a lot of those questions were easily answered if you looked at the data. It was few and far between where there wasn't something that was easily answerable. So I get why engineers don't want to put it there, but you got to paint a picture that allows people to actually review and certify it. And you often get in the daily field report just a brief summary that doesn't even detail the practices. And I know this from trying to answer things when I'm auditing the projects. I look at them and there's no meaningful text there. Um, and getting into these findings, it's missing so much information that you can't tell what was even done on a day. Trying to piece together the logs, a lot of times, if they have lift maps, they're incomplete, they're missing. Um, Areas worked. There's no accompanying lift map, so um, there's no volume. So how do you verify that proctor samples were actually used to the right quantities and how much is remaining? You start seeing tests all over the place using different proctors. To me, as a regulator, as an engineer, that's a big key. If you start seeing different proctors used between tests, more than likely somebody's just trying to fit the test results to a proctor to get it to pass, and they are making sure the material is properly constructed. Maybe it needs to be rejected, things like that. General procedures used by the contractor. A lot of times a spec requires a certain number of passes, lift thickness, conditioning, certain equipment. And that's all missing from the daily field reports. How can you, as an engineer, actually verify that the stuff was properly constructed when all this information is missing from the field reports? I don't understand that. I don't really get it. Um, but I guess that's just me. It's part of the reason I'm not an engineer, I think. I've mentioned it before. I'd probably pull my hair out or something being an engineer. I wouldn't ever sleep with some of the stuff that I find. Um, Audit findings like this too in the daily field reports. At least they were doing a report, and they were doing a fairly detailed report. They had quantities and things like that in this report. But every report for geotextile, there were 4 different types on the site. And they were different thicknesses, different types, different purposes. For roadway construction, there were for strength and separation. Landfill, you had different textiles for separation, cushion, and filtration application. Every last DFR, no matter which area they were working in, referenced it as fabric. There was no qualifier like, this was an 8-ounce woven textile or 16-ounce woven or a high strength textile. There were no qualifiers at all. There were no deployment logs, and there were no photographs that actually showed much detail. So how can you, as a certifying engineer, approve this? And how, as a regulator, how could you ever approve it? How do you know that the right material was used? There's no records that the right material was properly used there, and they had multiple materials on site. It's not like just one material was on site that you can make an argument that that's what they used. Um, More findings from the DFRs. I already mentioned you can't ascertain missing quantities, but the data then doesn't match when they do provide something. They'll say they took 15 nuclear tests, and you look at the logs and it only shows 10. Hence why the engineers don't want to provide more information. But that's all stuff that should be caught before the report ever goes out. Key weather events are missing. Rain. One of the sites we audited, it rained after moisture sensitive material was placed. There was no mention of protection, no mention of subsequent verification that the material wasn't damaged. I mean, those should be red flags to the engineer. Should have been addressed that day or the day after when you got the report, but nothing, and it should be addressed by the regulator. I don't know if it is or not. No narrative on how failing tests were handled, things like that. Um, Moving on to the test results and installation logs for geosynthetics. Um, these construction test results. They should meet the required project testing frequencies, meet the required project testing parameters, follow the approved testing procedures, clearly identify passing versus failing results. And then there should be repairs to properly delineate any failures. And you get into our audit findings, and, like I've said here, I don't know how many times I say it, but it's just mind boggling to me. Um, you're missing uh, data for dates of construction, which I already mentioned. 5 months of field testing logs were missing in one appendice. Were they there? Maybe that's an easy fix, but it doesn't give you any confidence when stuff like that's missing. Um, and how can you certify it as part of your package if it is missing? Um, your earthwork, not all tests are represented on a lift map. Tests are on the wrong or incorrect. They may be minor things. They might not be minor. Maybe stuff is legitimately missing. How does it give you confidence? You got to get that reconciled. Tests represent significantly more material than allowed by individual proctors. We run into that allowed. Incorrect proctors being used. We've seen that. We've seen where the values don't match the associated laboratory data. So you're getting a 95% compaction, meeting your requirement, but you don't have the right proctor value in there, and it might drop it down to a 93. Things like that. The moisture is different. Photographs clearly show a different area being worked than the documented source. Another reason why engineers don't like to put the photos in there. It gives you an opportunity to raise more questions. Test failures, again, I touched on this, not identified, not remediated. We run a project, and I think it was Shelby tubes where it had failed, and the Shelby tube had failed. They required, I don't know what it was, like an acre or something to be reworked. There was a certain area that needed to be reworked. No documentation of rework, no photographs of rework, as well as Shelby tubes were supposed to be taken in there to delineate the failure in perpendicular directions, 9 degrees. So, for example, north, south, east, and west of the failure. No documentation, no laboratory results for any additional Shelby tubes. Don't know what happened there. It's mind-boggling how you can turn stuff like this in. 1-point proctor verifications. I think I shared this with you before in previous webinars, but by AASHTO T272, there's 3 requirements, and basically that ends up being this blue box that's highlighted on this graph here. And your test for the 1-point should plot within this to verify the curve. Well, here's an example of a test that plotted down here, and it was stated to verify the curve. And that's impossible. That's not correct. And how do you as an engineer certify that? I don't understand that, but it even was worse than that. There were 25 out of 30 or so that actually failed to verify the proctor, that were stated to verify the proctor. And so I ask you, regulators, this is a question, you find this in a report that's submitted to you, 25 of these 30 tests didn't verify it when they're stated to verify it. What do you do? I mean, how do you make that work? I mean, what's the engineer required to do in that case? And engineers, what do? You receive comments back. 25 out of 30 stated to verify the proctor and don't. What do you do? It should never get to this point, but far too often it does. What do you do? It's kind of confusing. Some more audit findings, just highlight a few, dry cylinder moisture verifications as well of the nuclear gauge are performed. They're not correlated back to the proctor. When we correlated them back during our audit, 50% of them failed. So, you've got acres of material that's constructed here that's actually failing when you correlate it back. What do you do? It shouldn't ever be there. Outdated calibrations, no documentation about test penetrations. I'm just picking a few to keep moving. Desiccation allowed and approved. Here's a photo of desiccation. For that example, it was verbally approved by the regulator. So I think as a regulator, again, you guys need to be careful what you're saying, the reasoning behind this. The regulator said it would heal itself. There was a leak location survey being performed on the geomembrane, so they were less concerned about the compacted clay liner meeting the permeability requirement on the surface. Well, I disagree fully with that. One is you have a required thickness. That required thickness doesn't meet the permeability requirement at this time. I can guarantee you that. Um, and then again, it was approved by the CQA team and the PE on site in part because the regulator said it was okay. More audit findings, geosynthetics. Moving on to geosynthetics, just highlight a few here. Conformance test missing. Failures aren't identified. Failing material shipped to the site and used. It should never happen. It might be shipped to the site, but it should never be used. But it was. No approved inventory list. How do you know what's what? That's one of the big things. If you don't have an approved inventory list, it's hard for anybody to verify that the proper material was used. And on one instance, it was further complicated by overages when you start looking at rolls, and you had 50% overages. So a 400-foot roll you had on deployment logs is 600 feet plus of material. Doesn't make sense. Deployment issues and proper installation. One of the things here is, I've touched on it in other webinars too. Your textured surface, you have a textured material, they're deploying it one side up here, the other side up here. Which side's supposed to be up? It's supposed to be the stark side, but the engineer wasn't concerned about it because it was a small slope. I don't know that I agree with that, but I'm not an engineer. They're the ones signing off on it. But, there was a variance, but it wasn't included in the DFR. It was included in our DFR, but they didn't turn in DFRs in this case. And then the Cert report, it wasn't present as a variance in the Cert report. Trial seams, I could get into a lot of things here. I'll just highlight a couple things, failures not identified. Operators and equipment with failures were allowed to seam. Coupons weren't properly tested. Production seaming, you name it. Basically, we've found it in auditing, and it's unfortunate, but again, that's really the reason why I'm trying to share this with you. Hopefully, you guys can catch more of this as you're reviewing your own certification report, regulators as you're reviewing things, maybe take a more in-depth look at what's going on, compare things. More geosynthetics, non-destructive testing. One of the things that I wanted to illustrate here, equipment sometimes doesn't meet the requirements. Sometimes specifications exist, but they're not referenced, like the holiday spark testing. But here's from the Ohio Administrative Code, verification that whenever equipment is used to test an engineered component, the equipment is properly calibrated in accordance with the manufacturer's recommendations and specifications. Well, for air pressure test gauges and vacuum box equipment, I've never seen a calibration requirement nor a certification for them, a calibration certificate like we typically get with a tensiometer or the gauges, but the ASTMs actually require this. So does it meet the specification or doesn't it? Does it meet the code requirement? I've never seen one. Test results that raise questions, wrong equipment and proper dwell time for the air pressure. You start seeing 30-30 on every test, that should be a red flag. It takes a lot of time to try and pressurize a gauge to exactly 30. And then even in this instance here, it's the wrong gauge. The ASTM requires 1 PSI gradations, and this is 2. But these were all observed by an operator, all walked by an engineer during our audit. So how can this be signed and sealed? How can a regulator approve this? I don't understand, especially if there's, missing requirements in the construction documents. No. You see it quite commonly, unfortunately, in um, ASTM, or I mean, air pressure test specs now. They'll reference the ASTM, this one manufacturer's drop-in spec is commonly used, but it doesn't provide any minimum or maximum starting pressures, no required test duration, no pass-fail criteria in any of the governing documents, nowhere to be found. So you have, 9 months of air pressure testing with all kinds of different variations. Most of them say 30-30, unfortunately, but you'll have the occasional one that has like a 4-pound loss. Is that acceptable? They start at 28. Is that acceptable? What's acceptable? There's no guidance. So how can you be signing and sealing this? And as a regulator, without any guidance, how can you be approving it? I don't understand that. Non-destructive vacuum testing, equipment doesn't meet the requirement. ASTM calls for a gasket that's functioning creates a seal. A lot of times you'll see that it's improper, but yet, these are photographs taken actually from a project and there's issues with it. More of the geosynthetics. One of the things that raised questions on an audit we did is 10 vacuum test leaks. They were all observed on the same day early in the project. None after that. So magically now they have no leaks. If I find a vacuum test on a project that doesn't have leaks, I'm always skeptical of it. I'm skeptical of the quality. Usually it's going to be where CQA wasn't required to monitor full time. Improper repair procedures. Is this a gray area or not? Here the installer is grinding, they're actually abrading per the required documents, but they're not doing it properly. They're actually cutting instead of grinding, and they're damaging the integrity of the geomembrane. So what do you do there? Where does that fall within the regulations? Where does that fall within the requirements of a certifying engineer? Another gray area we see is this creased geomembrane from an ATV running over wrinkles. Talk to the engineer. If it's not in the specifications or CQA plan, they can't enforce it to be repaired. I disagree with that. But, from this slide, I'd ask you regulators, if gray areas exist in your regulations, how do you handle them? Especially if the photograph is a red flag to quality. And engineers, are you willing to go above and beyond the regulations to ensure quality when you do run into these situations? An example here from the Ohio Administrative Code again is that the engineer is supposed to make sure that there's a demonstration that the integrity of the engineered components was maintained during construction. So, to me, those creases need to be repaired. But, is that something that the agency is going to enforce or not? Can you identify it? Those are all questions that unfortunately I don't know the answers to, and a lot of engineers, aren't willing to gamble with it. Well, they are willing to gamble with it. They'll let it go, and maybe it shouldn't be let go. Um, yeah, destructs again, the same thing. And to speed it up here a little bit, I'm just going to skip over it. Photograph here really shows what I'm talking about there. This destruct, they actually took the time to bound it. So that's good. They got a bounding destruct, but they never repaired the seam. You look at different photographs, the seam was never repaired. It should have been repaired per the specifications required between the two failures, and it wasn't. So that's something to keep in mind when you're looking at photos. Other things, we've seen destructive laboratory results come back. I mentioned this, I'm sure, in previous webinar, but codes applicable to only shear coming back for peel, and same applicable to only peel are coming back on shear test. Doesn't make any sense. It doesn't give you any comfort of the laboratory testing personnel, which is why I think, you come across these, what do you do? It's just, yeah, mind-boggling, I guess is the best word I have for it, unfortunately. RFIs and variances, documentation showing these approvals should be included in the certification report. What we find is, they're often not referenced in the narrative. If they are referenced, they're not included in the report. So now you still can't piece it together. at least as a regulator, you can go back and ask for it, and get it. But, sometimes they're not referenced in the narrative, and you got to figure out why this was done. You really need to know the construction documents, the specs. You need to know the regulations, what's required. Survey data. Usually they're going to require survey tables showing that the elevations, grades, thicknesses, and such are all properly constructed and illustrated in a supporting table along with the as-built. Surveys usually are often the least commented on our section of the audits, at least the survey data themselves. Um, Observed issues, sometimes we'll see data missing from the tables, incomplete tables, transposed coordinates where eastings and northings are transposed. Sometimes that's just, using GPS, people have it switched backwards or something like that. But most of the time, the survey data is going to be, in pretty good shape. So that's a positive. The certification reports on the photos. As they say, a picture is worth 1,000 words. That's the old adage. And some states have detailed requirements of photographic requirements that need to be included in the certification reports. Others don't, unfortunately. I think it's a good idea to have the photos there and for regulators to actually evaluate them. Show the progression of the construction, show the construction processes are all common requirements. You should show issues that were encountered and how you resolved the issue as well. Wisconsin, you can see here, Wisconsin has requirements for photographs, including close-up photos of the construction processes, including clay liners, soil barrier, compaction equipment, deployment equipment, leachate pipe, and so on and so on. They got pretty detailed requirements there. And I think that's a good thing. I think photographs really are helpful in the certification process, both to the engineer and to the regulator, and making sure that the project meets the regulations. What we often find in photographs, of course, is, things are missing. They often raise more questions than answers, unfortunately. Um, photographs, you can look at the ones that I've presented here, they're all from audits. Um, Subgrade issues during deployment, improperly constructed features. I mean, we've seen features that are actually missing, both in photographs and in our walkthroughs, and things that are improperly constructed, things that contradict the manufacturer's guidance documents. It's an extensive list. But I'll get on to the as-built and the details of construction as-built. They should provide an accurate portrayal of the construction components, meet the regulatory requirements, obviously, and then reflect any variances from the approved design and plans. And what we often find is, things are missing. We've found, features that are supposed to be constructed, as I said, completely missing. They're not constructed in accordance with the details. When you start looking at photos, do site walkovers with no known variances or RFIs. Notes on the plan sometimes are incorrect. Wrong callouts like LLDP instead of HDP. Can be minor, but it's still a question. And, you got to be really questioning, did they install LL or did they install HD? You've got to dig into it a little further than just saying an answer as a typo. It really should be looked into. So it all boils down to the construction certification statement by the engineer. Again, we started in the beginning with this, performed, they're signing a report, signing and sealing, attesting that construction was performed in conformance, compliance with a permit or other guidance authorizing documents, such as the design construction plan, CQA plan, and technical specifications. But my question really to you as an engineer, could you sign and certify many of these examples that I've presented that we found in our audits? And as a regulator, could you accept that? How do you accept that? some of these things we've found. Then getting to my recommendations here for regulators. I think, training is critical both for regulators, engineers, training and experience in field construction for any of the engineered components that you're going to be reviewing is crucial. That way, you know what to identify. What I wanted to do was add a bunch of photos here from my Do You See What Glenn Sees that you can find on my blog. I think we're in week 26 of it or so. I put a photo up weekly. You can go to uncontained.co and find them or find them on LinkedIn. But I'm really trying to educate people through photos, get people thinking. I found it's a great way to educate people in my um, training and presentations I do at conferences and such. But you need to be able to look and see what's wrong and be able to identify something that's wrong. Scrutinize the photographs, have that questioning mindset. Visit the sites, they're extremely important. I know budgets, may not allow for a lot of that, but it's a recommendation. Take your own photos, inform owners of concerns promptly. Um, maintain that questioning mindset, like I said, interview CQA technicians, engineers, owners. Take notes while you're doing it. What do they say? Does it line up with a certification report that's later submitted? Thoroughly review the certification report. Avoid assumptions. Assuming that the engineer did it correctly. Avoid sole reliance on spreadsheets, tabulated data. Dive into the data. You really need to dive into the data if you're going to figure out if it makes sense or not. Again, inform the owner of serious concerns promptly. Some things are less serious than others. That might be typos, but the sooner the better as far as getting people on the proper construction path. Examine the regulations. If there are gray areas, do they need to be resolved in the next iteration when your rules are reviewed and approved? Moving on to engineers, I think really what this boils down to is the Cert report really is a culmination of all the work, much like field work is a culmination of all the planning and prep that goes into the project. The Cert report really starts with a complete comprehensive knowledge of the plans and the regulations. And the defendable Cert report starts before construction. You need to understand the regulations and requirements for the construction and certification. Know the contents of all the governing documents. Are there conflicts? Those conflicts need to be resolved before construction starts. Um, Training and experience in the field, I believe, is imperative. You know, that should be for not only all the engineers involved in the project, but for the CQA team as well. The best engineers that I've worked with all had time in the field. They started in the field as junior engineers, maybe even before they finished college. They were doing internships or summer work on projects, working earthwork, geosynthetics. And usually you're going to see that those people put out the best certification reports because they know what's needed. They know how to identify problems. They know to keep their finger on the pulse of the project, which is another important thing, I believe. Frequent site visits, including the pre-construction meeting. Everybody's about cutting costs competitively to stay competitive in their bids, but you got to have your finger on the pulse. You need to see what's going on site. Maybe with newer technologies, you look into, cameras or videos or drones or something to keep your finger on the project remotely. Daily communications with CQA personnel, prompt review of the paperwork daily. Again, I've mentioned that before, it has to be daily. We review all project photographs daily. That's the best way you're going to figure out if something's wrong, but you need to have the photographs. You need a mandate that your technicians take photographs so you can see it and address issues and concerns immediately. Reviewing the laboratory data promptly. I've mentioned this before. Multiple sets of eyes are best. Um, Implementing best practices or industry standards that go above and beyond the governing documents. That should be standard procedure, and those should be documented in the narrative. And then, lastly, carefully review the contents of the certification report before it goes out for before you sign and seal it. a lot of these things should be caught. Missing appendices, typos, things like that should all be caught before it ever goes out. So that's really what I have to offer on certification reports. It's at the hour mark now, I know, so I'll try and get to the questions and answers. I want to thank you for coming out. My next webinar is going to be compacted clay liners, tips to make your project run smoother. That's going to be on Thursday, August 21st. I think if I got the date correctly there. Third Thursday in August, if that date is incorrect, for some reason my mind's questioning it now. 12:30 p.m. Eastern. So I hope to see you there. And with that, I'll try and get to see if we have any questions and answers here, if I can remember how to do that. So what did I need to do? Oh yeah, I think I need to make big here. Make big, okay. Questions and answers. Well, there are no open questions that I see right now. So yeah, if anybody wants to ask a question here, I'll take a moment here to wait. And in the meantime, I appreciate you guys coming out today, taking time out of your day to see what I had to say about certification reports. And, I'm hopeful that this webinar was helpful to you guys and ladies out there, everyone out there, and, you know, that there's some positive things taken away from this so that 10 years from now, I'm not saying the same thing, but I'm saying how we vastly improved and how great we're doing. So I look forward to that day. And with that, I guess there are no questions. So thank you very much. And I'll see you next time.